these are the original great big rectangular switches, which basically, I know it's a matter of taste, but I don't like how they stick, which obviously isn't really a huge problem. It could have been renewed, cleaned up, or what have you. Yeah, not only are they, I think, a bit clunky, but also I don't want to make great big holes in anything really, just to fit them in. I can't fit them into wood because they're designed to go through a thin sheet of metal, and basically I don't like them. I've been trying to work out how to wire up an electric window motor. Now of course a motor, let's call it a round thing like this, usually DC motors can rotate either this way or this way, up and down in fact. And you can do that simply by reversing the polarity on the wires from plus there to minus there, to become minus there to plus there. And it will run in the opposite direction. So the question then, so that's the basic idea, but the question is, how do you actually wire up a circuit that that does that with a suitable size switch? They used to use switches with lots of pins on them that could do all kinds of things all at the same time. But I want something a little bit more elegant than that, and that's what I'm hoping to achieve by the means of some relays. Now there's lots of things you can do with relays. What is a relay? What is a relay? A relay in essence is an electromagnetically controlled switch. And if you remember your school science or physics, you'll know if you have a coil of wire, that produces a magnetic force if you apply voltage to it. In this case it will be probably 12 volts. And that magnetic force, lots of little arrows there, can be used to attract a switch contact, so that when you apply the circuit here, this switch here gets sucked, as it were, closed, so that there's now a circuit from here to here. If this is a voltage here, now this will also be a voltage, and that circuit can be used to power something. Now there are different types of relay, apart from different voltage ones. Obviously 12 volts is what we're interested in here because most cars run on 12 volts, but actually it could be 240 volts or something if you wanted that to operate on mains voltage. But beyond that, there are different types of 12 volt relay. So we have the same idea, of course. You've got the electromagnet, which we can apply a circuit to, but the circuit coming in, which is switched by this magnet switching on, often has two different positions that it can switch to. So at rest, before you've done anything, likely enough the contact breaker will lie across that direction. And because it's lying across that direction, it is already connected to a terminal here, and that's before we've even done anything. So we call that one the normally closed. So normally, before you've done anything, it's normally closed, a circuit is through here. And this one over here is normally open, or NO. And that only closes if we apply voltage here. So even in this simple, quite simple form, we've got 1, 2, 3, 4, 5 different contacts, and a lot of car relays are actually that very sort. So we have, I think that's called a single pole dual throw, SPDT, because there's only one pole that goes over, and it's got two positions, so 1, 2, So hence it's single pole dual throw. And this is the sort of relay that you see most often in those little square boxes, like this one. This is indeed a relay like that. As you see, we've got 5 pins on it, and just from memory I know that these two here on the outside are in fact those two, and these two here are the normally open. So that one is this one, that one is this one, and the other one is the middle one. So that is an extremely common sort of relay. As well as that, you can also get relays like this one. There's also another one next to it, which also switches at the same time. And so both of these relays, when this electromagnetic switch gets switched on, both of these switch at once. And that can be very useful in some situations. In fact, I seriously considered it in relation to this project, but it turns out that's no good. Anyway, that would be called dual pole, dual throw, DP-DT. So 2 poles being switched, and each of them has got 2 positions, so dual pole, dual throw, as opposed to the more basic sort, which is SPDT, single pole, dual throw, which is this one. Okay, basics of relays. So it's an electromagnetically controlled switch, and before I forget to mention it, I'll also say that none of this cares about polarity at all. So you can switch 12 volts to that way or that way or what have you, and this one can be wired either way up and it has exactly the same effect. So there's no, for example, if you put 12 volts up here and earth down here, it's exactly the same thing as putting 12 volts down here and earth up here. So there's no problem with as it were, the north and south of the magnet going in opposite directions, because we're just dealing with a piece of metal here that doesn't care. Alright, so those are the switches that I think we're going to be using. And so how about this circuit that we need to switch an electric window then? So here's our motor, and it has 2 wires coming out, and depending which way it's wired up, it can go that way or it can go that way. And we want to be able to choose that by the use of preferably two little switches, 2 little cute switches, which I'm hoping to use rather than great big clunky affairs you might have had originally, even in the original Gilburn, which did originally have electric windows. There's great big square switches like this, and I'm not happy really to use those. So how to go about selecting which way round to wire it up then? Well, one of the things that is apparent is that we need to switch both ends of this wire, or of these connections, needs to be either positive or negative. So since that means that these ends need to be the things that get switched. So let's put a pole on each end, and they will switch between either of those positions as we want. Now, when we're not doing anything, we don't want there to be any kind of short circuit, so when it's at rest, then both ends of this, as I've shown it here, need to be to both 12 volts or both earth. Now I'm going to choose earth actually, because that means that the wiring to the motor is actually not connected except when it's operating. So I'm going to put earth up here. So this is a symbol for an earth, and up here a symbol for an earth. Okay, but we have our electromagnet coming on to do something here. So we will put the little coil thing, and that is going to go to earth as well. As I said, it doesn't matter which way around the coil is. This is just a question of drawing it. So we shall put the coil going to earth, and there needs to be a switch. Now this switch here, which is the one that switches the coil on, is now a little switch, little cute one, or even an electronically controlled switch, and that's the light switch, the light duty switch I should say, which is the one that we can actually see. So that will be going to 12 volts. Same thing over here. So I'll draw that. So this is 12 volts over here. And again, this is our light duty switch, which we use to switch the heavy duty switch. Okay, so when we press this button, this electromagnet will energise, and if we press this button, that one will energise. So what we're going to do is we're going to apply 12 volts to the spare terminal here, and 12 volts to the spare terminal here. So what does that mean? It means that when I close this little light duty switch and it powers up this electromagnet, it means that this pole is now pointing, will switch down to here, which means there will be a circuit running from 12 volts into the motor, so 12 is on this side, and going out to the earth on that side. And similarly, so we now take our finger off the up button, let's say, and we switch this one, and this means that this one will switch to 12 volts, so 12 volts will now appear at that end, and the circuit will run in the opposite direction. So what we're doing here is we're using the relay to choose at each end of the motor whether it wants to be at earth or at 12 volts. And the choice which of those switches switch is going to be determined by these, what I keep calling light duty switches, hopefully little tiny ones, or even electronic, let's say computer controlled switches, which aren't capable of switching a large enough current to power the motor. So there has to be only milliamps to make these switches, make these relays go over, whereas the current needed to drive the motor will be several amps. And that's what I'm going to do. One of the problems that people have with these relays is understanding which the pins are. But you will find that most of them have got a picture on, rather like this. This is stamped on to the metal, but it could be painted, printed. It could be on the side, could be somewhere. But there'll normally be a picture like this. And if you look at it, the picture is showing the electromagnet here, going between pin 85 and pin 86, and the switching contact, this one is going to either 87 or 87A, and that's what the it aligns with my drawings, if you like. And the way I look at it is these sides here, this one parallel to each other, are the coil, the electromagnet, and this one gets connected to this one if a voltage is applied across there. But in the case of a 5-pin relay like this one, in that case there is a contact between there and there. The middle one is optional, so the normally closed, some versions of this relay, the middle pin is missing, and so there's only a normally open, there's not a normally closed contact present at all. So this is the optional one, if you like, which is the normally closed, but they all obviously have the normally open contacts. So 5-pin relays are a bit more useful. They fit in the same type of socket as the 4-pin type, but obviously the middle pin is missing. So anyway, look out for those drawings. So you've got 85 and 86 operating the magnet, and we've got 30 going to 87 or 87A depending on its position. As you may have seen on my previous work, the ability to wire these things up neatly we've got to have two of these things in each door. The ability to wire these things up neatly is important. So there we have what will be in the door. So I'm going to use this relay base that locks together. There'll be two of these, whoops, one in each door. And in fact, here's an example of a 5-pin relay and a 4-pin relay, and as you see, the layout is identical apart from the 4-pin relay has got the middle pin missing. So in fact, in this case, there is no normally closed contact, there's only a normally open one. So this is the difference between a 4-pin and a 5-pin automotive relay. So they both fit in the same type of relay base, but obviously the wiring in here for this one wouldn't be able to be used because there's nothing to connect it to. But I have got lots of these spade connectors that go in here, and I'm going to use those. So these are the spade clips, and as you see, they have the little tag on the back, and it's that enables them to clip into the plastic housing, so that when you push the relay into it, the spade clips stay where they are. So I'm going to connect up my relay bases, and as you can see, I've already done this one, which is actually the earth. So I'm going to do the 12 volt side. It's not too bad, and that is going to loop over. So I'm going from pin 87, which is the normally open. This is the this is normally closed, this connection. And Jessica's banging on the gate, would you believe? Anyway, I'm going to do the... There, that's Jessica. Do you recognise the sound? So I'm going to go and do the ones for the normally open, which is 12 volts. In fact, there's only 2 of these rather than 4. These are earths. Oh, Jessica. So I'm going to go and do that. I better not take too long about it, I think. Hello, Jessica! She doesn't realise I've got my hands full. Now, one of the things is I'm going to put 2 into 1 here, and one of the things that of course happens when you get the insulation side by side like that, it tends to go kind of rectangular. Hello, Jessica! So I'm just going to squish it up a bit before putting it in the terminal. And that is 12 volts incoming, and that's going to go to the normally open connection. So there we have two relay bases ready to go, and I still need some other ones obviously from the motor itself and also the switches. I'm really going to get that dog in. She didn't want to come in a moment ago. Ah, dear, oh dear. Come on then. No? She still doesn't want to come in. What you'd like me to do is go out there and play, wouldn't you? I'll take for a walk for a little while. Do you know what I mean? Alright. Right, Jessica is now under the table. So I'm going to do the same thing for the other relay block. To be honest, this crimping into these spade clips is for use in the relay blocks is actually easier than I thought it was going to be. So all my previous effort of buying pre-terminated relay bases was probably not necessary. So here we have a chain of 4 earths with a wire going out, obviously, and this relay base is actually just over here somewhere. So I'm just going to copy what I did before. So we've got an earth for the motor, so it's the normally closed connection. So I'm going to go with the, which is the centre pin, which is 87A, I think. I'll just push that in there. Will it make it click? Ah, did you hear that? A little clicky noise. And here, through a mass of temporary connections like this one, I can demonstrate the thing working. Now this simulates, if I connect this one, will get up, and the other one, it will go down, connecting to 12 volts. So I just need a switch on the end of this to go to 12 volts, and we will be away. But anyway, proof of concept, going a little bit further, here we have it. There we are. Apologies for the hat hair. I've been wearing a woolly hat because it's so blinking cold. So where is my hat? Yes, apologies for the hat hair. This is my Bond Bug woolly hat that I blinking well need because it's so blinking cold at the moment. But having noticed that the window was actually out of shot, I'm just going to demonstrate that again. So one of the 2 wires connected to 12 volts and the other connected to 12 volts. There we are. The reason it's so slow is because of the extended wires and all that running on low voltage, so I'm not concerned about that. But the proof of the pudding is indeed in the eating, and this relay pack does the job, and it will be mounted inside the door, right up here, well away from hopefully any water ingress. So here's the kind of door more back together. So the 2 relays are actually mounted on these screws inside the door, and yeah, it's just a bit tidier than it was. But as before, we just have to put either one, oh, wrong one, or indeed the other. So finally, for now, I've got this little switch panel, which is, well, it's a mock-up really, because I haven't decided where this might go. It could end up being part of the top of the tunnel in front of the gear lever, and I've even marked some potential holes, but I don't want to go there just yet because it's embossed, obviously may not be that suitable. So I've just, for the time being, I've just mocked this thing up to give the idea, and these are the little chromy buttons that I have used. So here we have, I hope you can see that. So little lightweight tiddly buttons like that, which I hope you will agree is a little bit more elegant than the great big rectangular switches, which basically, I know it's a matter of taste, but I don't like. Okay, and so therefore I do hope that you agree that this is nicer than this. So that's the end of this sub-project, for now at least. And I shall move on to something else shortly.